Okay, class, you liked the first one, so here we go, part two. Well, lesson two. So, get out your note page, or you can use the notebook I gave you when you picked up your school books, or you can use a notebook that you already have, or just paper, or you can type these if you want, whatever works best for you to take your notes. We are in Module 1. This is Lesson 2, and it is actually Lesson 2, Part A, because I am going to split this lesson into 2 days. Today, this lesson is going to be about the multiplication of exponents. If my writing is messy, too bad. Okay, so let's start out with what we know. We know what we know from yesterday. We know that exponential form looks like this, where the x is a number we call the base. And this, the n, is a number we call the exponent, or you'll also hear it called the power. And you know that this does not mean x multiplied by n. It means, remember, we said it yesterday, let me say it again. This is not x times n. It is x n times. So we do x n times. So if you look at this, x is not multiplied by n. X is multiplied by itself. As an example, let me show you a quick example reminder. I know most of you got this, but humor me. Let's do 5 base with an exponent of 3. Now, a lot of people will say, Mr. Bailey, the answer is 15, because they do 5 times 3. And they just do 15 because you've been doing multiplication for years and you're used to it. Well, this is not multiplication by itself. This is exponents. So what we really need is this is not 5 times 3. It is 5 3 times. There's 3. 5 is multiplied by itself 3 times. The 5 comes from the base. The number of 5s comes from the exponent. And then you have to actually, if you want to know what the answer is, you do 5 times 5, which is 25. 25 times 5 means 5 to the third power, not 15. It is 125. If you tell me it's 15, you are 110 off. So don't do it. You'll be wrong. So that's yesterday. Moving down our page a little bit. Today, we will learn about questions that look like this. 3 to the 5th times 3 to the 7th. So what happens if we're multiplying 2 exponents together? We want to simplify this. I'm going to put the problem over here and what I want to do over here. So we want to simplify this to make it more understood, to use less ink, whatever you want to do. We want to simplify. The best way to do this is to stretch it out. Let me stretch out these two things. So let's start. I'm going to use my orange. We're going to start by stretching out 3 to the 5th. So this is 3 5 times. So we do 3 times 3 times 3 times 3 times 3. There you go. And we're still going to do multiplying it by 3 to the 7th, which is 3 7 times. So we do 3 times 3 times 3 times 3 times 3 times 3 times 3. And that is 7 times. Now, so we stretched out the whole thing. 3 to the 5th, 3 5 times. 3 to the 7th, 3 7 times. That's a lot of 3's, but they're all being multiplied together because it's multiplication right there, and the exponents have multiplication inside of them, so it's all multiplication. So how many 3's do we have all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 3 12 times, which means we know that 3 5 times, the orange, times 3 7 times, the blue, equals 3 12 times altogether. So 3 to the 5th times 3 to the 7th turns in to 3 to the 12th. So question, do you see the shortcut? And if I have time, I'll turn this into an ed puzzle and I'll ask, do you see the shortcut? And if you do, yes. If I don't have time to turn this into an ed puzzle today, just tell yourself the shortcut or be happy it's not an ed puzzle quiz. To help you, let's write this again. Do you see the shortcut? Some of you see it. 3 to the 5th times 3 to the 7th equals 3 to the 12th. There's a shortcut in here. Let me see if I can help you find it by circling that, and circling that. Does that help you see the shortcut? 5, 7, 12. Hopefully you do see the shortcut. The shortcut is 5 plus 7 makes 12. That's a fact family. That is connected. So, again, the trick is 3 to the 5th times 3 to the 7th. Here's the middle step, equals 3 to the 5 plus 7 equals 3 to the 12th. That is the rule. To prove the rule, you stretch it out. Or you can just use the rule. I'm going to ask you today, use the rule, because I really don't want to see you writing so much. Use the rule. So let's go down here. Today's rule. This works for any number. So if we have x base with an m exponent times x base with an n exponent, the rule is the x just goes to the m plus n. Now, the important part about this is, remember, the bases must be the same. If you look at this, the base for both of these is x. This is a rule when the bases are the same. You just add the exponents together. So for today's work, because this is only part A, you're not going to work on all the pages from lesson 2. You're actually just going to work on exercises 1 through 20. So let's do a few of them together. Let me get my paper out. So those are your notes. Please keep your notes in a safe place because we will talk about them tomorrow. And let's look at this is the problem with doing a video because I am missing my lesson 2. Oh, I found it. Let me come back. Just looked a little bit ridiculous on video. Maybe I'll edit it if I have time. Anyway, starting on page 11 of your workbook. Page 11 of your workbook actually has the rule we just discussed. So If you forget the rule or you lose your notes, you can just remember it's on page 11. Let's do exercise 1 together. Exercise 1. 14 to the 23rd power times 14 to the 8th power. Well, we know that because of the rule, we just need to do 14 to the 23rd plus 8. So we can write this problem like this, we can write like that, or simplify all the way, do the addition, and we find out it's 14 to the 31st power. And I'm going to skip over here to exercise 5, where we see that it does not matter if it's a number or a variable, because we have a to the 23rd times a to the 8th. We could just say a to the 23rd plus 8, which is a to the 31st. It's important you see, I did both of these at the same time so that you can see, if it's a 14, we do the same rule. If it's a variable, it's the same rule. Whatever the value is for the base or the exponents, it's the same rule. Do not be nervous about a variable. Variables are just numbers we don't know yet. Exercise 2, we have a negative 72. You might be freaked out because you see negative in parentheses. Don't be freaked out. It's just a base. It does not matter what the base is. We just do the same thing. We do the base and we add the exponents. And so we get the base and we add the exponents. Negative 17 to the 23rd. Works the same with variables. The base and we add the exponents. This is how we multiply exponents. Pause the video, please, and I would like you to try exercises 3, 4, 7, and 8 on your own. So pause the video and then come back when you're ready to see the answers. Okay, so hopefully you paused it and you're not just skipping ahead to get it done. But exercise 3, you should have done 5 to the 94th plus 78, which gives you 5 to the 172nd power. Same thing works with the variable. B to the 94th plus 78 equals B to the 172nd power. Exercise 4, the base is negative, but the base is fine. We just do 9 plus 5, add the exponents. We're multiplying exponents, so we just get negative 3 to the 14th power because we're multiplying. Exercise 8 was asking you to think backwards a little bit. We have negative third to the 9th times negative third to a variable equals negative third to the 14th. Well, you know that we just have to combine the base. So this is negative 3 to the 9 plus x equals negative 3 to the 14th. So now just a little bit of algebra. 9 plus x makes 14. Count on your fingers if you have to, but you should get that x is going to be 5 because 9 plus 5 makes 14. Moving on to page 12. So on page 12, we have a little bit more practice, and you might be a little bit confused because you're thinking, wait, Mr. Baylor, wait. These have more than 2. We're multiplying more than 2 things. Well, the same thing works. We have 3 exponents, but they all have the same base. So the rule is we just add all 3 exponents. We do 4 plus 6 plus 13. As long as the bases are the same, we can combine the exponents. This gives us 9 to the 23rd. Try doing exercise 10 for just a minute. Pause the video and work on it. Okay, we're back. You should have seen, okay, 4 numbers might freak you out, but then you see, wait, all the bases are the same. So just combine the exponents. 3 plus 5 plus 7 plus 9. Lot of addition later, we get 2 to the 24th. Much simpler to write this than to write all that. Exercise 11, you are still multiplying exponents, but this time you see that the bases are different. So what you might want to do now is, what I like to do, you can see I have a bunch of different colored pens. You can use colored pencils or pens or whatever you have. You can see that there's a base of 6 and a base of 6, so those can go together. You also see a base of 4 and a base of 4, so those can go together. So what you're going to do, put the 4s together. Do not put the base, you cannot put different bases together. So the 4s and the 6s are going to be separated, but you can still add the exponents together. 5 plus, just like that. That's the first step. You put the bases together, and then you can add, you get 4 to the 12th times 6 to the 19th. Now we are done because the 4 and the 6 cannot go together. They are different bases. Try exercises 12 and 13. Pause the video and see if you can do what I just did for exercise 11 for 12 and 13. Okay, if you paused it, we're back. Let's work on it again. Find the what we can call like terms. Find the things that go together. That's a phrase you might want to remember. Probably heard it before. Like terms. Like terms go together. Unlike terms do not. Like terms like each other. So, the like terms with the base of -4 are, the exponents are 2 and 3, so we put those together. Then the other base is 17, and 17's exponents are 5 and 7. We separate our like terms. Now we just put them together. We get -4 to the 5th times 17 to the 12th. And that's where we stop because those bases do not go together. Exercise 13, I'm just going to give you the answer. If you have more questions about exercise 13, you probably should call me or give me an email, do a private session, or look on Khan Academy because there's extra practice with this on Khan Academy. After you do this, you can combine the 7s to get 7 to the 6th, and you combine the 15s to get 15 to the 3rd. Oh, there's a trick to this one. Did you see it? There's a 15 by itself. So this is 15 2 times. This one is 15 1 time. If there is no exponent, it just means there's a 1 there. It's an invisible 1. This is 15 2 times. This is 15 1 time. When people write this, they do not write the 1 because you can see there's 115. They save a little bit of ink, but if it confuses you, add the 1. Every time you see a number, you can just add the 1 there. That's why 15 is to the 3rd, because this has 2 and this has 1. It's just oftentimes not written down. So even if they don't write it down for you, you still have to find it. Exercise 14. Now this is a little bit tricky, but they're being a little bit nice to you right now. I'm going to cover up something. You look at this and you say, Mr. Baylor, 2 to the 4th and times 8 squared. Those are different bases. And you said only the same bases can combine. So you're thinking, I can't put those together, Mr. Baylor. Except they give you a little hint because 8 to the 2nd is also 2 to the 6th. Let me show you this real quick because 8 to the 2nd is 8 times 8, which is 64. 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. 6 2s. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So both of these are the same. But if we write it this way, we can combine the bases. If we change the 8 squared to 2 to the 6th, we can combine bases. So what you thought was impossible actually is possible. you just get 2 to the 4th plus 6th, which is 2 to the 10th, which is our answer. Now they gave you the conversion here, just so that you know how to do it. Same thing works with exercise 15. Started with 3 to the 7th times 9, and you say, Mr. Baer, those bases are different. Yes, they are different, but we can make them the same because we take 9 and we say, well, 9 is just 3 squared because 3 times 3 makes 9. Now we change the base. The base changes from a 9 to a 3, so we can combine them to make 3 to the 9th. So now it's asking you, exercise 16, can you simplify this? Well, can I change the bases to match? And the answer is no, you cannot change the bases to match. 5 and 2 do not share any roots, so the bases don't match. So this says, you just say, cannot be simplified. Because the base 5 and 2 do not share roots. And we'll talk more about that later in a later lesson. If you need a break, by the way, remember you can pause a video anytime you need a break. If I'm going too fast, you can always rewind your video. But let's look at exercise 17. Ooh, here we go. Multiplying exponents, only this time there's coefficients. These numbers in front of the base, those are the 2 and the 17, those are called coefficients. Coefficients. I kind of squeezed it in there. So when you're multiplying something like this, you multiply the coefficient. Remember what I said before, like terms. Coefficients are both regular numbers, so those can be combined. So what I like to do sometimes, I like to stretch this out. This is 2 times x to the third. And 2 sets of parentheses next to each other means multiply. So multiplied by 17 times x to the 7th. Remember, we could just stretch it out. Now, so it's all stretched out instead of all squeezed together with no multiplication symbols. I just stretched out and added the multiplication symbols. Now, there's a property called the commutative property of multiplication. If I'm multiplying, I can move the numbers around whatever I want. So I'm going to put the like terms next to each other. The 2 and the 17 go next to each other, and the x bases go next to each other. And suddenly this problem gets a little bit easier to understand. It's called the commutative property. When everything is multiplication, I can move things around. Now I do what I can know how to do. 2 times 17 is 34. X to the third times x to the 7th. Well, our rule for the lesson, the bases are the same, so just add the exponents. So we get 34x to the 10th. And that is your answer. There we go. Exercise 18, we don't need the commutative property. Exercise 18 is asking us to distribute. Distributive law, or the distributive property, I like to remember that distribute means to pass. So what's going to happen is, you should remember the distributive property or the distributive law from previous years. When something is outside the parentheses, it gets passed to everything on the inside of the parentheses. So this a on the outside gets multiplied by everything on the inside. So the a gets passed to the a, so we do the a times a. Plus, because plus is inside the parentheses, so the plus goes in between the two sets. And then the a gets passed to the b, a times b. So after we pass, this is what it looks like. Now here's another trick that I hope you remember from exercise 13. We have A's next to each other, but remember that when there is no exponent, the exponent is 1. So this A really means A to the first, and this A really means A to the first. Now we can combine, because we do A to the 1 plus 1 plus A times B, which cannot be simplified as just A times B. So our final answer is going to be A, 1 plus 1 makes 2, plus AB. We cannot simplify that anymore. That's the distributive property. So this is written like this. Okay, still with me? Great. If you're not with me, be sure you ask for help. Send me an email, send me an invite to a Google Meet, check Khan Academy for extra work. But we have 2 more questions to talk about. Let's look at number 19. Number 19 is the same thing, distributive property, except that this time instead of the A on the outside of the parentheses, we have a B. So pause the video, take a minute, and see if you can solve exercise 19 the same way that we just solved exercise 18. Okay, hopefully you looked at the work and you saw, okay, well, you said to yourself, this is the distributive property. So the B gets passed to the A, and the B gets passed to the B. So we do the B times the A, plus the B on the outside times the B on the inside. B times B. And the plus, remember, came from inside the parentheses. Now, B times A cannot be simplified, so we just leave it alone. We just say B times A. Although most people tell you just go in alphabetical order. So instead of BA, I'm going to write AB to go in alphabetical order. But B times A times B, same thing. And hopefully you remember, wait, there's a B by itself, a B by itself. Well, this B is actually B to the first. This B is B to the first. So these B's, B to the first times B to the first is going to be B to the 1 plus 1. So our final answer is going to be AB plus B to the second. AB plus B squared. Or if you like putting the squares first, you can just use the commutative property again and write it just like that. It gets a little bit more complicated for exercise 20 because there's 2 things in parentheses. Look at this. We have A plus B times A plus B. It is still the distributive law, the distributive property, except it gets a little bit more complicated. Let me show you. First, remember, this A gets passed to everything in the other parentheses. So this A goes to this A, and this A goes to the B in the other parentheses. You have to do the same thing with the B. This B goes to everything in the other parentheses. It goes to this A, and it goes to this B. So follow along, and you have to do, so you see you're doing 4 different multiplications. A, follow this arrow, times A times A, plus, and we're doing pluses because that's what's in the parentheses. The next blue arrow, which means the A goes to the B, A times B, plus, we finished following the A arrows, now we need to follow the B arrows. B goes to the A, so we get B times A, plus B, follow the other arrow, times B. See, 4 arrows, 4 different sections. Now we can start combining them. We can start putting it simpler. So remember, first thing I'm going to do, A by itself is A to the first. A by itself is A to the first. b by itself, b to the first, b by itself, b to the first. So let's combine these together. A to the first times a to the first, I'm going to get a squared. B to the first times b to the first, b squared. Those are exponent rules. What about these ones in the middle? A times b, well, we can't simplify that, so just put ab. This one, b times a, cannot be simplified, so you could put ba, but remember I said go in alphabetical order. So just move the a first, ab. Now we have a squared plus ab plus b squared. There's something else we can combine here, because AB and AB look exactly the same. In fact, I have two ABs here. So I have A squared cannot be simplified, the B squared cannot be simplified, but now I have two ABs. So just write that down, two ABs. And that's your answer. That's the simplest it can get. So if you've been following me through the whole video, we just finished the math for the day. Hopefully you follow along. Hopefully you know how to do it. You will have more practice with this skill tomorrow when we talk about dividing exponents. But that's 20 exercises. That seems like a good day to me. Remember you can collaborate with your friends and you can help each other work on this. You can give me a call or invite me to a Google meeting or send me an email if you need my help, and there will be more practice for this skill on Khan Academy. So please go on Khan Academy and do the exercises. Have a great day. Tomorrow is dividing exponents, which you will get quickly also. Have fun.